G'day everyone there. This video is question number 11 out of 3C. Thank you very much, Alan Sadler, for the question. Great question. I've summarised the information here. Let's have a quick read. It says a body is initially at rest, stopped, at the origin. Initially at rest at the origin. Whoops, got to add something else in. There we go, got that one as well. Initially at rest at the origin, and moves in a straight line such that its acceleration t seconds later is given by this. Find the value for t for when the body is next at rest and the displacement at that time. So that's what we need. So what are we going to do? Well, I think what we're going to have to do is integrate this one, use this and this, which that will tell me that the plus c part is going to be 0. That will then give me a formula for velocity, and from that formula of velocity I'll be able to let that equal 0 and find the next time that it is at rest. Let's see how we go. So if I integrate acceleration with respect to time, dt, I'm going to get velocity with respect to time. Okay, maybe I should have written these the other way around. So therefore, v of t is going to equal the integrated version of this, which is going to be 18t minus, raise the power, divide by the new power, 3t squared. So that one there is my velocity. Now, I should put a plus c here. I'll put it in a different colour. Now, the reason I'm not going to worry about that is because the velocity equals 0 when t equals 0. So when I put 0 in here and here, all of that cancels out, and the answer has to be 0, so c has to be 0. So I actually don't have to worry about c in this case, okay, in this case. Let's factorise this. Would this not be 3t out front of 6 minus t? Now if I let vt equal 0, then my first solution is going to be t equals 0. Well, that's good, because I already knew that. So that's good that I get that solution, or this part, or t equals 6. So when t equals 0 or t equals 6, the velocity is 0. Now the question said, when is it next at rest? T equals 6 seconds. And then it says, what's the displacement at that point? Well, I've got to integrate this to get displacement. Wouldn't the displacement formula be the integration of the velocity formula? And if I integrate this, you could do it here, but I wouldn't. Do it here. Raise the power and divide by the new power, 9t squared. Raise the power and divide by the new power, minus t cubed. And again, it would be plus c, but when x equals 0, t equals 0. So again, this one I can ignore. So there's my formula for displacement. To answer this part, all I've got to do is take my 6 and put it into here. 6 sixes are 36 times 9, what's that? 270, 54, 324. Okay, so this would be x of 6. And 6 cubed is 216. There we go, work that one out. There's your answer as to where it is. Somewhere positive, 108, I think. 108 metres in front of the origin. So this part here is fine. This is fine. 108 metres, done. Hopefully that makes sense. That's a fairly stock standard question. You kind of should know where you're going with that. Now, this question relies on getting this here. Now, if you didn't get that there, you're probably going to get this question wrong. Because at 6 seconds, the velocity is 0. Now, that's probably that it's headed off in this direction in the positive direction. Maybe, I don't know yet. And then it stopped at 6 seconds, and then it's decided to go back the other way. Okay? So it's made a change of direction at 6 seconds, or it might have changed direction. It might have just stopped, paused for a moment, and kept going. If that was the case, it could have done something like that, but it could have also done that, where that point there is t equals 6. So we've got to be aware of this change of direction thing, or could be a change of direction. Okay? If the velocity goes to 0, it might just pause for a moment and keep going, or it might go back the other way. So because of this, what I'd be doing here, a couple of different things. I could integrate the, where have we got? Integrate the velocity with some limits, 5 and 7, the absolute value of x of t. Oh, actually, sorry, absolute value of v of t. I'm integrating the velocity to get the displacement. I could do that, right? Now, that's going to work absolutely fine, and if you're happy with that, throw that in your calculator, see what you get. Here's another way to do it. Knowing that there's a change here, I could go the absolute value of x of, now I'm working in displacement, x of 6 minus x of 5. That will tell me the positive version of the distance travelled between 5 and 6, plus the absolute value of x of 7 minus x of 6. That will give me the absolute value of the distance travelled in that second. Add the two together and I'll get this answer here. Either way of doing that is good. Play around with both so you know, and make sure you get the same answer for both. That's question number 11. Some good thinking involved in here. This one always trips people up. So make sure you see that. Whenever you're talking about distance, you've got to think, did it turn around? If this said displacement, it's a different question. It's a different question for displacement. Hope this one's helped. Catch you later.